Hello everyone, today we'll be doing the following Math AA high-level question. Prove by mathematical induction that 5 to the power of 2n minus 2 to the power of 3n is divisible by 17 for all n is a member of the positive integer subset. So, let's start off by writing our starting condition. Let P of n be, and in this case we'll say 5 to the power of 2n minus 2 to the power of 3n is equal to 17a. This implies that it's divisible by 17, and we have to also write that a is also a member of the positive integer subset. Right, so now we have to test if our starting condition is correct. Therefore, prove that P of 1 works. So, 5 to the power of 2 times 1 minus 2 to the power of 3 times 1 is equal to, well, 5 squared is 25, minus 2 cubed is 8, which is equal to 17. Therefore, our starting condition works. Now, we will have to make the assumption that assume that n is equal to k. Therefore, that leaves us with 5 to the power of 2k minus 2 to the power of 3k is equal to 17a. And we make a box around this because this is really important. However, quickly, this will be helpful later. This will leave us that 5 to the power of 2k is equal to 17a plus 2 to the power of 3k. And we will put another box around this. All right. So now let's go for our inductive step. We have set ourselves up. So let's prove that when n is equal to k plus 1, it works. So what does this leave us with? 5 to the power of 2 times k plus 1 minus 2 to the power of 3k times k plus 1 is equal to 17a. Perfect. So now, what do we do here? We expand the indices, and then we will separate them. So 5 to the power of 2k times 5 squared minus 2 to the power of 3k times 2 to the power of 3 is equal to 17a. Right. So now we will use the assumption that we made up here, this one right here, to prove that this relationship does work. So we will substitute in what this equation left us with. So therefore, we have that 25, we will have that 25, which is just this 25 squared, times 17a plus 2 to the power of 3k minus 2 to the power of 3k times 8, which is just the 2 cubed, is equal to 17a. Right. So now we will expand this once again. So 25 times 17a plus 25 times 2 to the power of 3k minus 2 to the power of 3k times 8 is equal to 17a. Right. So now, what do? We will separate these. So 17a times 25 plus 17 times 2k plus 2 to the power of 3k is equal to 17a. Well, actually, this should be more 17b, but it really does not matter. And then So now what do? We see that we have two 17s here and here, so that means we can factorize it. Perfect. So we can see that we have 17s on both sides that can be divided. Therefore, that means that they can be cancelled, which means that this expression here was in fact divisible by 17, which we have therefore proved our assumption. And now we would write our conclusion or conclusive statement. Thank you very much.